About biconnected components, articulation point, and how to find articulation points. Okay. Now, what is an articulation point? A vertex V in a connected graph. So the graph is undirected. Is an articulation point if and only if the deletion of vertex V together with all edges incident to V disconnects the graph into two or more non-empty components. Okay. Now, if you delete, you can see here, if you delete E, it will create two graphs. That means E is the articulation point. Now, if you delete B, it will create B and adjacent graph. Now, two graphs are there. It will create two graphs. So, B is the articulation point. E is the articulation point. Now, if you delete D, it will create two graphs. So, D is the articulation point. Similarly, if you delete H, it will create two graphs. So H is a articulation point. But A is not articulation point because if you delete this one, still it is a single graph. J is not articulation point. If you delete J, still it's a single graph. Okay. Next, what is biconnected? A graph G is biconnected if and only if it contains no articulation point. Okay. So the question is it biconnected? No, because articulation points are there. Okay. Now how to now suppose a graph is there A, B, C, D. So it is biconnected because no articulation point is there. Similarly E, now it is not biconnected because articulation point B is there. Okay, but if you connect A with C, now it is biconnected graph because no articulation point is there. So this is biconnected graph, this is not biconnected graph because here articulation point is there, here articulation points are there, here no articulation point is there. Okay. Now the presence of articulation point in a connected graph can be an undesirable feature in many cases. Suppose it's a communication network or transmission network. Now if B is not working properly, then we can't transmit data or material or fluid from this graph to that graph. Okay. Now if this particular is not working properly, so no problem. Anyhow, we can transmit data from H to I, D to K, or J to B, or H to E. But if this is not working properly, then we can't transmit data E to H, B to F. So total network hampered. Okay. So it is articulation point. Sometimes articulation point is undesirable. So our aim is to identify this particular articulation point and make it biconnected. Okay. So how to now? So the question is how we can identify the articulation point and how we can convert this into a biconnected graph. Now in this case, if you connect this, now if you delete this one, still it is single graph. So now E is not biconnected articulation point. Now D is not articulation point. Now if you connect this one, say this one, now H is, if you do, we have removed all the articulation point. Now if you connect C and F or A to I, then and A to I, then we can convert this graph into biconnected graph. Okay. Next question is how to identify the articulation point. Now it's a graph. Okay. Now first of all we have to apply depth first search to generate depth first tree. Okay. Now here we have applied this is nothing but the depth first tree for this particular graph. So 1 is the root, this is the root node. Okay. Now 1, 2, 3, 4, these are called prenum values, and the 1, 1, 1, these are called height of x. Okay. So if it is x, then height of x. If it is x, then prenum x. Okay. So prenum x is 2. So x is equal to 4. Prenum x is 2, but height of x is 1. So question is what is prenum x and height of x? To the left of each node V is prenum V. So left of each node, so left part, these are called the prenum, already you know. Okay. The number assigned by a pre-order traversal of T. Okay. So pre-order traversal means if it is a tree starting from 1, So pre-order means what? Root left right. So pre-order traversing means what? Root left and the right. So root is one, first root, then left, it is also root, second visiting, second, next left, root left, it is also root, root left, it is also root left, no right, then root is over, left is over, then right. So 3 4 5, okay, then 6 7 8. So we can put values by the pre-order traverses. First visit, second visit, third visit, fourth visit, fifth visit, 6 7 8 9 10. Okay. Next, to the right of each node V in a new number that we shall call highest of X V. Okay, highest or height. So we can put highest, not height. Okay, so you have put highest of, not height. So highest of V. Okay, so these are the number for highest numbers, 1 1 1. So these are prenum, this is highest. Okay, P. Let W be the highest node in the tree that can be reached from V by following down 0 or more solid lines. So how to get the highest values? Let W be the highest node in the tree, then that can be reached from V. Suppose 1 is the highest value that can be reached from V, say V is equal to 4, by following down 0 or more solid line, 1 2 solid lines, and then going up at most 1 broken lines. This is one of the one broken line. Okay, so you can see here, this is depth, it is a graph. We have convert DFS and it will create depth first tree. Now 1 to 4 there is a connection, 1 to 2 there is also a connection, but it is not part of the tree. 1 to 2 the connection is not part of the tree, but it is a part of the graph. Okay, so that's why it is in broken edge. Similarly, 3 to 4, 2 to 3 solid line is there, but in actual graph the connection with 2 is 1 or 1 5 and 8. So there's a broken line from 1 to 2, 2 to 7 and 2 to 5, 2 to 5 and 2 to 8. 2 to 8 broken lines are there. Okay, so broken lines indicate not part of the tree but part of the graph. Okay, and solid line indicates part of the tree as well as part of the graph, both. Next, so for each V, going down 0 or more solid lines and one broken one broken line. Okay, now for this particular one, highest value is 1, prenum is 1. So going down 0 or more solid lines and 1 broken line. So just see the prenum value 1, make it 1. For this particular value, going down, going back. So here highest value is 1, its prenum value is what? 1, that's why it is 1. In this case, going down 1 or 0 or more broken lines. Okay, return back via broken lines. Here is the highest value, make it 1, so it's 1. In this case, now here only one solid line is there but no return back broken line, so you just copy the prenum value. So 4, that's why it is 4. In this case also one solid line is there but no return back, so you just copy the prenum, so that's why it is 4. You just copy this value to here. In this case, 0 or more solid lines but one broken line, so one broken line, its value is 1, so that's why copy 1. Now for this 5, 0 or more down. Okay, you can see here 0 falling down 0 or more solid line. Now 5 down 0 or more, 1 and 1 return back in where 2. Now its prenum value of 2 is 6, That's why copy 6 here. For this particular, no down and broken line, so just copy the prenup value. In this case, down one solid line, one broken line, its prenup second prenup value is 6, that's why copy 6. In this case, no zero down, zero or more solid line, but one broken line is there, its prenup value is 6, that's one 6, not single. Okay, not return back here because only one, not two. So the minimum value is, the maximum value is one broken line. Okay, not two broken line. So here should be 6, not 1, this one. Okay, now if you select this one, that means 1, that means what, two broken lines are there from this place to that place, then this place to that place. Okay, so it is 6. Now the next part is how to use these numbers to identify the articulation points. Okay, now how to determine the articulation point. The root of t is an articulation point if and only if it has more than one child. Question is one articulation point? It is a t is the root. This is a t is the root. No, it's not articulation point because one child is there, 4 is there. But here it is dotted line means what? It is not part of the tree, but maybe the part of the graph. So it's a one child is there, so it is not a articulation point. One is not, one is a root, but one child is there, so that's why it is not a articulation point. Any other node V. Okay, now any other node V is an articulation point if and only if it has a child x such that highest of x is more than prenup V. Node V is an articulation point if and only if it has a child, so V and x. Okay, so if highest of x is more than prenup V, if this value is more than this, then V is an articulation point. Okay, now you can see here, now child is 4, this value is not prenup of x. Now is 4 is articulation point? If is 4 is articulation point, its child is what? Is 4 is articulation is 4 is articulation point, its child is 3, its highest value is 1, which is not more than this prenup x. Okay, if you can compare this, so V is equal to 4, x is equal to 3, highest of x is 1 and prenup V is what, 2, so highest of x is more than prenup. Now this condition is false because highest of x is what, 1 and prenup V is what, it is 2, so this condition is not true. This condition is not true means V is not articulation point, that means 4 is not articulation point. Similarly here, the children are 10 and 9, its highest value is 4 and 5, which are more than 3 prenup value. So highest of 10 is more than prenup value of 3, so 3 is articulation point. Similarly, you can see here the child of 2 is 5, his highest value is 6, which is greater than equal to 6. Okay, it's a greater than equal to 5 is there, then second is articulation point. Similarly 5, its child 6 and 7, these values, that 8 value is more than 7, so 5 is a articulation point. Similarly 7 is articulation point. You can see here its value is what, 6, which is not more than 9, so 7 is not articulation point. Similarly is 9 is articulation point? No, 9 is not, 10 is not. Okay, next is 6 is articulation point? No, 6 is not articulation point. So articulation points are 3 because 5 is more than 3, 2 because 6 is equal to, greater than equal to 6, okay, and 5 because this 6 or this 8 is more than equal to 7. Okay, so using this highest and prenup value, we can identify articulation point. And how to remove articulation point? You just connect few lines. If you connect this one, okay, if you connect this one, if you delete this one, still it is now we can connect this one also. Thank you very much.